If you want a tree to heal, the science says you actually need to cut it while it's actively growing,
Right.
like while the sap is running. Welcome to this deep dive. Today we're looking at some field notes from Kesser and Steen. They're these two nature and innovation students.
Yeah.
And they're tackling this massive crown reduction on some mature oak trees over at Aunt Green's garden. So our mission today is really to extract the modern principles of pruning that work with the tree's biology.
Which, means basically tossing out the old rule book.
Yeah.
Because Aunt Green's local nursery actually advised against touching those oaks entirely.
Oh, wow.
Yeah. But Kesser's following his mentor, Dr. Shigo from the U.S. Forest Service, and he championed this major paradigm shift.
Yeah.
Basically, pruning during the active growth period, leaves and all.
Okay, let's unpack this, because pruning while a tree is actively growing, it sounds incredibly counterintuitive.
Right.
I mean, isn't that like performing surgery while the patient is running a marathon? Why wouldn't you just wait until winter when the tree's dormant?
That is a great way to put it, actually. But what's fascinating here is that a dormant tree is essentially a defenseless tree.
Wait, defenseless? Really?
Yeah. So when an oak is in active growth, its internal systems, the sap flow, the cellular regeneration, they're fully operational.
Ah, I see.
So you make a cut while it's, as you said, running, and the tree immediately mobilizes its natural defense mechanisms to seal off the wound.
Okay, so if you cut in winter, that open wound just kind of sits there.
Exactly. It sits there for months, completely vulnerable to fungal infections.
Wow. Well, that completely flips the script on how we manage a canopy. And I guess it explains the incredible patience Kesser and Steen are using on Aunt Green's oaks.
Oh, absolutely. They're going for this invisible crown reduction.
Right, yeah. We know they avoid flush cuts to protect the branch collar, but the real magic is this multi-year, two-step process. They actually document it with photos.
Yeah, the color coding.
Yes. They only take the outer one-third of a branch first, and they mark that in red in their notes. But I don't get why they wouldn't just take the whole branch at once and save a trip. Like, why the wait?
And it's because you want to manipulate the tree's chemical signals.
Oh, okay.
Right, so by only removing that outer third while the leaves are actively photosynthesizing, you force the plant's growth hormones to hit a roadblock.
Huh.
And those hormones, they have to redirect into the remaining side shoots. So if we connect this to the bigger picture, over the next year or two, those side shoots bulk up.
So they essentially transform into the new crown. The tree does the heavy lifting of restructuring itself.
Precisely. You cut a little, you shift the weight, you step back, and you just let the biology take over.
That's wild.
Yeah, and then once the tree has naturally balanced its growth into those side shoots, you come back for the final reduction cuts.
Right.
The ones they map out in blue.
It's like a transition from being a sculptor who just chops away wood to like a director guiding the tree's energy.
That's a really good analogy.
I mean, I get the biological elegance of that, but let's talk about the physical reality. Reducing a mature oak crown means dealing with thick, dense hardwood. You can't just snap those off.
No, not at all. You really can't. And the field notes highlight a crucial mechanical reality here, which is you need supersized loppers.
Supersize!
Yeah, it's pure physics, The tool relies on a fulcrum and leverage to multiply human force.
Right.
If your arms or shoulders are aching after a few cuts, your tool's handles are just too short. You aren't generating enough mechanical advantage to cleanly sever green oak.
Which also explains their strict protocol on greasing the lopper mechanics, like before and after every single use.
Yeah, friction is the enemy of leverage.
Exactly. Here's where it gets really interesting, though. Once you've leveraged off all these massive oak branches, you're left with a mountain of heavy debris. I mean, you can't just leave a pile of oak limbs sitting in Aunt Green's yard.
Right, but they don't leave it as a pile. They actually upcycle those exact branches to construct hügelkultur raised beds.
Okay, I've seen that term, hügelkultur. But how does burying a bunch of dense oak branches actually help a garden? Doesn't the wood just get in the way of the soil?
You'd think so, but it actually creates a self-sustaining ecosystem beneath the surface.
Oh, really?
Yeah, so in hügelkultur, you use those thick, heavy oak logs as the base layer.
Okay.
And then you pile smaller branches, leaves, and soil on top of that. And as that dense hardwood slowly rots down over years, it acts like this massive underground sponge.
Oh, so it absorbs water during rainfall and then slowly releases it.
Exactly.
Yeah.
Along with a steady drip of nutrients back into the plant roots above during dry spells.
Wow. So they are literally turning the discarded canopy of the oak into the foundation for an entirely new garden ecosystem. That is a brilliant closed loop.
It completely redefines yard waste. I mean, the tree's removed biomass becomes the biological engine for the new garden beds.
So what does this all mean? We started with the heavy canopy, and we end up with this patient, multi-year partnership with nature.
Yeah, it really is a
Yeah.
partnership.
But there was one detail in Kesser and Steen's notes that really pushed this idea of manipulating biology even further. We can effectively time travel by hacking a tree's healing processes or by using cuttings to skip years of seed dormancy. What other slow-moving natural cycles in our backyards could we manipulate to speed up ecological growth?
That is a fascinating question.
Definitely something to chew on the next time you're out there deciding where to make that